Assalamualaikum and salam sejahtera. Subtopic 4.2 Functional Groups and Homologous Series. Learning outcomes for 4.2 Functional Group and Homologous Series. At the end of the lesson, students should be able to A. Define functional group. B. State functional group of the following class of compound. C. Identify functional group in a given compound. D. Define homologous series. E. Explain general characteristic of homologous series. Functional group definition. Functional group is an atom or group of atoms in an organic molecule which characterize the molecule and enable it to react in specific ways, which determine its chemical properties. Next, we will identify and classifying functional group of different class of compounds. Class of compound, we have alkane example. So functional group none. Alkene, structure of the functional group must have a C double bond C. So the name of the functional group carbon-carbon double bond. Alkene must have a C triple bond C. So the name of the functional group we call a carbon-carbon triple bond. So we can label, we can identify the functional group. Carbon-carbon double bond, we circle and name the functional group. Okay. C triple bond C. So the name of the functional group carbon-carbon triple bond. Next, the class of the compound we have are aromatic or a ring. So the name of the functional group is a aromatic ring. Alcohol, class of compound. So the structure of the functional group is OH and the name of functional group hydroxyl. Haloalkane. Symbol is X that represent for the fluorine, chlorine, bromine and iodine. So the name of the functional group halogen. Ether, COC, and the name of functional group is alkoxy. So this is the general formula for this compound. Right, and then we can identify the functional group for the compound. Okay, aromatic ring. Hydroxyl, we circle on OH. Cl, halogen. COC, alkoxy. Next, aldehyde. Structure of the functional group C double bond OH. So the name of the functional group carbonyl. Ketone. Okay, the general formula are C double bond OR. Name of the functional group also carbonyl. Carboxylic acid C double bond OOH. So the name of the functional group carboxyl. Ester is a derivative of carboxylic acid. C double bond O R. So the name of the functional group is ester or carboalkoxy. Acyl chloride C double bond OCl. So the name of the functional group is acyl, right? And then we can identify the functional group for each compound. For aldehyde, okay, we circle on C double bond O, carbonyl, ketone, the name of the functional group carbonyl, carboxylic acid, C double bond O OH, carboxyl, ester, C double bond OO, acyl, C double bond OCl. Next, we have a anhydride class of compound, C double bond O, O, C double bond O. So the name of the functional group anhydride. Amide, the structure of the functional group must have a C double bond ON. So the name of the functional group amide or carboxamide. Amine must contain N. So the name of the functional group amino. Nitrile, structure of the functional group C triple bond N, and the name of the functional group cyano. Okay, we can identify the functional group anhydride. We circle for the functional group for the anhydride, amide or carboxamide, C double bond ON, amino, and cyano, C triple bond N. Okay. Example 1. For number 1, identify the functional group in the following molecule. A. So we have functional group is a C double bond O and H2, that is a carboxamide or amide. For molecule B, content of functional group is a carbon-carbon double bond. C, we have a COC or alcohol C, the name of the functional group. D, aromatic ring, double bond, alternately. E, we have a C double bond OO, the name of the functional group carbo alkoxy or ester. F, C triple bond N, so the name of the functional group is cyano. Okay, and then general formula for the homologous series. Okay, we have a alkene. General formula CnH2n plus 2. So ending name for the alkene ANE. Alkene. General formula CnH2n. Ending ENE. Alkyne. Carbon-carbon triple bond. CnH2n minus 2. General formula. Ending name YNE. Alcohol. General formula ROH. OL. Aldehyde. RC double bond OH. AL. Al. Ketone. RC double bond OR. ONE. Carboxylic acid. RC double bond OOH. Oil acid. Amine. RNH2. Amine as a ending name. Amide. RC double bond ONH2. Amide. And then where is R is normally referred to alkyl group. Alkyl group with a formula CnH2n plus 1. And then for the alkyl group, for the cyclic compound, we will reduce 2 atom hydrogen for cyclic compound. Okay, so R is a alkyl group. Refer to the alkyl group CnH2n plus 1. So we reduce one hydrogen atom from a alkane formula. Okay, example methane. Okay, formula is CH4. Molecular formula CH4. So the alkyl group will be a methyl. So we remove one atom hydrogen to become CH3. Ethane. CH3 and as a alkyl group will be a ethyl. CH2CH3. Propane. CH3 so will be a propyl. Butane, butyl. Pentane, pentyl. Pentane 5 carbon. Right. For the cyclic compound, so we will reduce 2 atom hydrogen for the cyclic compound for the alkyl group. Okay, so we're starting from propane for the cyclic compound. Propane, CH3, CH2, CH3. We have C3H8. So will be a cyclopropane. C3H6. Okay, so these are example of alkene and cycloalkene. Butane. C3, CH2, CH2, CH3 and cyclobutane C4H8. Pentane 5 carbon. So will be a cyclopentane. Pentane general formula C5H12. So cycloalkene we remove 2 atom hydrogen so C5H10. Alkene and cycloalkene. So we're starting from the propene. Okay, propene CH2 double bond CH3. So will be a cyclopropene, same number of carbon. Cyclopropene. Okay, cyclopropene. C3H4. Butane. Cyclobutane. Pentane. Okay, example 1 pentane. So cycloalkene is a cyclopentane. And as your reminder, alkene and cycloalkene belong to the same class compound but different homologous series. Okay. Example, methane, ethane, propane, butane, pentane is a homologous series of alkene. Cyclopropane, cyclobutane is a homologous series of cycloalkene. Okay, and then as a summary, so for general characteristic of the homologous series has a general formula. Example, alkene, CnH2n plus 2. And then for the homologous series is the successive member differ by only a CH2 group and have a similar chemical properties because have the same of the functional group.